morning, good evening, good afternoon, wherever you may be watching this from. This is Konya Sabina with addition in mathematics. We are continuing on vectors. Now this is just a subtopic, which is how to draw a closed triangle. So you may be given a scalar equation, which is in the form of ax plus by, ax plus by plus c is equal to 0 right there in this particular form, and then you are asked to draw a closed triangle. So this line represents this scalar equation right there. Now in the exam, it's not like you will find this line already drawn for you. I already did it, but let me give you a few key steps of how I did it for me to reach there. I did it like this. First of all, you need to find the x and the y intercepts. Or simply just say, you need to find a coordinate when x is equal to 0 and when y is equal to 0. We'll call these two coordinates. Okay. So you need to find x and y intercepts usually for most equations. But for this particular scalar equation, first start by finding the x-intercept and then the y-intercept. You can do that. So this is my x or y plane. My 0 is here. I did not extend the negative part because I just wanted to show you the positive part. I wanted to show you the positive part so that I don't complicate matters. In the exam, usually you'll be given certain position vectors, or you'll be given a scalar equation. So scalar equations may vary. One might cut there, one might cut at 3, one might cut at -3, which is down here. I did not show the negative part of any of the axes. So you do this. When x is equal to 0, so you will say 0 comma something. Then when y is equal to 0, you will say something comma 0. We can call this A, we can call this B. I hope that's clear. So what I'm trying to say, in this scalar equation, we'll say x is equal to 0, and then we'll say y is equal to 0. These are the x and the y intercepts. So y is equal to 0, it means the y coordinate is 0, x is equal to 0, the x coordinate is 0. Then we proceed. Let us start with when x is equal to 0, it means -3 multiplied by 0 plus 6y minus 30 is equal to 0. This is simply 0. So you have 6y minus 30 is equal to 0. 6y is equal to 0, is equal to 30. Then 6, you divide both sides by 6. Then there you have a 5, y is equal to 5. So which means our a is 0, 5. This is why it is cutting the y-axis at 5 as an intercept. And then we will say when y is equal to 0. So y is equal to 0, this we can just call it our b. You don't need to label them. This is just for us not to get confused. So you don't need to label them, it's not needed. We will have something comma 0. It means we are saying -3x plus 6 multiplied by 0 minus 30 is equal to 0. Minus 3x is equal to 30. Minus 3 minus 3. Then 3 can go instead of 1 into 30, it is 10. Take note of the negative sign right there. X is equal to -10. So it is -10, 0. This side of the x-axis, we would have put our -10. So this is going to go down all the way and cut the x-axis at -10, 0. But it's not needed. You just need to, your closed triangle doesn't need to do that. You can do that, but this is just an example, so it is best you do that. Okay, so we have those intercepts. Then to draw the closed triangle, just draw your scalar equation like that. And then you think of two position vectors. How can we know of two position vectors? First of all, we need to find 2 points that are along this line. So usually you will not graph using graph paper. You will not use graph paper to answer this question. So you need to be very careful. What can you do? What you do is this. You think of coordinates. You start testing coordinates. So you test different coordinates, and I'm saying that I'm going to choose the positive side. So for me, I already tested 2 coordinates. The 2 coordinates are 2, 6 and 4, 7. The good part is that when you find a coordinate, for example 2, 6, this one here, and then you prove it. You say minus 3 multiplied by 2 plus 6 multiplied by 6 minus 30 is equal to 0. So here it's minus 6 plus 36 minus 30 is equal to 0, minus, rather positive 30 minus 30 is equal to 0, 0 is equal to 0. So this is a valid solution. When you know it's a valid solution, you can try another coordinate. So if you try 4, 7, it will also give you a valid solution. 0 is equal to 0. After you find 2 coordinates that are close to each other like that, the easiest way you can do it so that you don't get confused is find the normal vector. The normal vector are these constants. So vector n is equal to a, b, and then vector n is equal to a is negative 3, b is positive 6. It means direction vector d is equal to, we can just change, we flip these. The 6 goes up, negative 3 goes down. Now, when there is a negative, what you can do is you make it positive. Follow me here. So what we have done, we have flipped and we have changed the sign. Flip and change the sign. If you don't want to change, in this particular case, you need to change the sign. But if it was, for example, positive 3 and then 6, it would have become any. So you can, in this case, since both of them are positive, you can make any of them negative. Negative. Or, so that's negative 6 right there. Or negative 3, 6. This or that is okay. Alright, so let me not confuse you with too many things. Too much writing. Then we know our direction vector 6, 3. The best thing we can do is that this direction vector, we know a certain number can go into both these two numbers. So let's reduce it to its lowest form. So therefore our direction vector will be equal to 2, 1. Now what have you done when you know this direction vector? This direction vector will help you to find any coordinate. Any coordinate. So for example, we only knew of 2, 6. So we have 2, 6 plus the direction vector, which was 2, 1 when we reduced it, 2, 1. It means when we add the vectors in the rows, this is 4, 7. So this 4,7 is the same 4,7 there. And these are position vectors. Hence, to draw a closed triangle, you would just draw a vector that has its tip along this scalar equation. So 2, 6, just go 2, 6. And then you will have your 4,7, 4,7 right there. So these are 2 points that have followed each other. Then if you want to make it look more like a triangle, you can shorten your scalar equation. You can do this. It's alright. Okay? So ignore this part that I've raised, but if you look at this, it has now become a closed triangle. Usually you can just leave the scalar equation. So maybe what I mean is you should have just left it like this. But leaving it the way I raised it like this is just for you to see that it actually forms a closed triangle. Thank you so much for watching. This has been Cornelius to be in the hand. Bye bye.